So one thing we know about how humans learn language and sort of what people do with language is that we can generalize from very, very small amounts of evidence, right? The sort of amount of, the number of words that a typical child language learner has access to, for example, is orders of magnitude smaller than the number of words that, sort of typical natural language processing model from today is trained on. And one thing that seems important for making that possible is that people understand a lot about the structure of language learning problems. They understand that once you've heard, certain kinds of sentences, then you should also be able to understand certain kinds of other, So like if I tell you that this is a red ball and that's a green bat, if you know what red ball means, if you know what green bat means, you know what a green ball looks like, you know what a red bat means. And people are able to sort of take individual words that they've learned and put them together in new ways, really like without thinking about it and without too much difficulty at all. And this does actually still seem to be a sort of fundamental problem for a lot of the language processing tools that we have right now, is sort of understanding language that looks very different from the language that they were trained on, taking concepts that were expressed in the data and combining them in new ways that look different from the ways in which they were combined. And in some sense, this is a fundamental challenge, right? The thing that makes language work, the thing that makes it useful for human communication is that we can communicate ideas to each other that, I can say things to you that you've never heard before, but that you immediately know how to understand. And so, a big part of what we work on is just figuring out how to build models for natural language processing that can do the same thing, that generalize in human-like ways, and especially from training data sets that are sort of human-sized and not internet-sized. So how might we actually go about this problem of building language processing models that can learn from small amounts of data and generalize in more human-like ways? And one way of doing that, one way of sort of reverse engineering what it is that people seem to be doing when they make generalizations about language is actually thinking about generalization specifically, right? And if you sort of take as a first-class principle the idea that models should be able to generalize, or people should be able to generalize to combinations of words that they've never heard before, this is actually something that you can use as a principle for developing machine learning methods. And so, another thing that we've done in our group is develop new kinds of machine learning models that sort of have baked into them the expectation that models need to do well, not just on data that looks like the data that they've seen before, but on sort of hypothetical alternative versions of the data in which pieces that look like they don't go together at all have actually been combined. And you sort of, the way this works in practice, you ask models to essentially hallucinate versions of the data set, versions of individual examples in the data set that look very different from anything that they ever saw, but that combine pieces that they saw before. And you ask them to make predictions that are sort of as reliable or as robust on those imagined examples as on the real training data that we as the model developers have provided. And it turns out if you do this, you generalize better, not just to more sort of weird-looking hallucinated examples, but also to real-world data, right? And that by doing this, you get models that do actually make, in some cases, the same kinds of generalizations that people do.